Hi, I am Dr. Sinjab. This is Quick Guide to the Management of Keratoconus course. In this part, I will finalize talking about the diagnostic tools. I will talk about the parameters. I hope you will enjoy it. In the last video, I talked about corneal imaging. We discussed the devices of corneal imaging, including the topography, tomography, and anterior OCT. And I discussed also the maps derived from tomography. They are the anterior sagittal curvature map, the anterior and posterior elevation maps, and the pachymetry map. In this video, I will talk about the parameters. The parameters are the numbers and values that appear on the main page of the Pentacam or other devices. The parameters include numbers and values derived from the anterior corneal surface, posterior corneal surface, pachymetry map, and those related to the anterior chamber. The only one important thing on the posterior corneal surface is the posterior astigmatism. We have to take this astigmatism into consideration in refractive surgery and also in calculating of corneal astigmatism, total corneal astigmatism for decision making in some management modalities in keratoconus and ectatic corneal disorders, as will follow later. Starting with the anterior surface parameters, we have the SIM-K, including K1 and K2. I mean by the SIM-K, those numbers in the central 3 millimeter zone. We have the astigmatism, Q value, and quality specification. Quality specification is the quality of the capture. Now, it should be displayed as OK in a white box. Otherwise, when it is in yellow or red, we have some information are missing, so we have to recapture the patient. We have to memorize the following numbers. The maximum K, of course, the maximum K is not displayed in this slide, but we will find it in another place later. Now, the maximum K, which is the highest K all over the cornea, should be less than 47.2 diopters, and the difference between both eyes in regard with the Kmax should be less than 1.9 diopters, and the difference between Kmax and K2, I mean steep K, should be less than 1 diopter. Regarding the astigmatism, the normal astigmatism should be equal or less than 1.5 diopters. Otherwise, there is a suspect. In regard with the astigmatism, I have to talk about a very important concept. It is the disparity between manifest astigmatism and topographical astigmatism. Now, the disparity can be caused by numerous causes, such as misalignment during taking the capture, corneal irregularities, hotspot syndrome, tear film disturbance, corneal opacities, and lenticular astigmatism. Starting with misalignment. I'll show you this picture to see how misalignment during taking the capture affects the shape of the anterior curvature map. This patient has regular astigmatism, as you see here, with the rule astigmatism as a symmetric bow tie. Now, this patient now is looking aside, but in a horizontal direction. I mean, there is a horizontal displacement of the centration or the fixation target. In this way, the symmetric bow tie is still symmetric, but with the skew radial axis index, which is very abnormal in this case. Now, the same patient is looking downward. Look at the symmetric bow tie it became asymmetric bow tie. Now, the case will be more complicated when the patient is looking in an oblique direction. So whenever we have an abnormal shape of the curvature map, it's better to recapture the patient. And don't forget what I said before in the last video. This affects also the elevation map because the normal shape of the elevation map is an hourglass, symmetric hourglass. Whenever we have a skew in the hourglass, then it might be due to misalignment during taking the capture. Corneal irregularities for any reason, such as form frost keratoconus, irregular astigmatism, keratoconus, and other ectatic corneal disorders. The hotspot syndrome, indeed, it is an entity including many other things like the corneal irregularities and tear film disturbances, however. But I would like to focus on the hotspot that is created by the usage of soft contact lenses, especially soft contact lenses. This is a case of a hotspot, inferior hotspot. As you see, it is an inferior steep or maybe round type also. This is caused by hypertrophy of the epithelium in this point because of the constant rubbing of the contact lenses over this point of the epithelium. Just stop usage of the contact lens for maybe 2 to 4 weeks lets this hotspot disappear. Tear film disturbance, either an increase or a decrease in the amount of the tear film may cause disparity. As in this case, this is a dry eye. After treatment, look at this. This is before treatment. Look at the 4 maps. They are very irregular, but after treatment, they became more regular. At the same time, when we have excess tears, the computer will understand the spot over the tear film as a hotspot. So just give the patient a tissue and dry the eye and everything will be better. Corneal opacities for any reason, such as after PRK, this is haze, subepithelial haze, or anterior stromal and Bowman haze due to PRK. This is a severe case, of course. This problem may cause disparity between manifest astigmatism and the topographical astigmatism. But the most important thing between these causes is the lenticular astigmatism. Whenever you find disparity or difference between manifest astigmatism and topographical astigmatism, please take the patient to the slit lamp again and dilate the pupil and do a dilated full examination of the anterior segment of the eye, including the lens on the slit lamp, because in many cases you may have subtle cataract that causes this disparity, which may be missed during the first very quick overview by the slit lamp. Now we will come to the Q value. The Q value represents the shape of the cornea. I mean the slope of the cornea. Now, the slope of the cornea is the relationship between the central part of the cornea and its peripheral part. I'll explain this by these illustrations. Suppose we have the cornea, suppose this cornea takes a shape of a sphere. In this case, Q value equals 0. In this case, the cornea will play a role of a multifocal lens. Why? That's related to the incident angle of incidence and angle of refraction. As we know, in the sphere, the incident angles and the refractive angles are larger at the periphery than those at the center of the sphere. In this way, the parallel rays are not refracted in equal angles, and this will cause a multifoci lens effect. Now, suppose the cornea is prolate. In this case, the Q value becomes less than 0. It means that negative. It is negative. In this cornea, the central part of the cornea is steeper than the peripheral part, and this will compensate for the difference in angles of incidence and refraction. And this is the normal cornea. It takes a prolate shape. Sometimes the cornea may take an oblate shape. The oblate shape consists of a flat central part in comparison with the steeper peripheral part. In this case, the Q value is positive, more than 0, and we can find this after correcting more than -3 diopters of myopia. In this case, the cornea will play a role of a multifocal lens. This is because the problem is exaggerated by the difference in curvature, in addition to the original difference in the angles of incidence and refraction. Sometimes the cornea may take a hyperprolate shape, where the Q value is very negative. This can be seen in keratoconus and ectatic corneal disorders, and also after correcting more than +3 diopters of hyperopia. In this case, the central part is much steeper than the peripheral part, leading to a multifoci effect. Now, what is the normal range of the Q value? The normal range is between 0 and -1, but the ideal value is -0.27, where we don't find any spherical aberration. Whenever the cornea becomes prolate, it means that it takes negative Q values, then we will have negative spherical aberrations. And when the cornea becomes oblate, it means that the Q value becomes more positive, and we will have positive spherical aberration. Of course, the spherical aberrations cause halos and glare around lights, especially at night. So to sum up, we have to look for K readings. They should be less than 47.2. The difference between maximum K reading all over the cornea and the steep SIM-K should be less than -1 diopter. And the difference between both corneas in regard with the maximum K readings should be less than 1.9 diopters. And we have to pay attention to the difference between manifest astigmatism and topographical astigmatism. And finally, we have to look at the Q value of the anterior corneal surface. It should be within the range of 0 to -1, but the ideal value is -0.27. Now coming to the thickness parameters. As you see in this image, we have 3 major landmarks on the pachymetry map. They are the thinnest location corresponding to the thinnest point in the cornea, the pachy apex corresponding to the center of the cornea, or sometimes it's called the central corneal thickness, and the pupil center corresponding to the location of the center of the pupil. You can see also the maximum K readings. It means the K max, but nothing to do with this here. So back to these 3 landmarks. As you see in front of each of them, there is the thickness of the cornea corresponding to this point, and the X and Y coordinates, supposing that the origin of these coordinates is the pachy apex. Therefore, you can see the X and Y of the pachy apex are 0, 0. According to this, of course, the pupil center and the thinnest location are measured. What we have to know here is the normal difference between in thickness and regard of thickness between the thinnest location and the Peki apex should be less than or equals to 10 microns. The other thing is the new definition of thin cornea. The thin cornea is defined as a very normal cornea with normal tomography but less than 470 micron in at the thinnest location. Or when we have abnormality in tomography, then it is considered as thin cornea when it is less than 500 microns. The other thing, we have to look at the y coordinate of the thinnest location. The y coordinate represents the vertical displacement of the thinnest location. The vertical displacement can be seen in ectatic corneal disorders. Now, as seen on the bar in this picture, the cornea is normal when or the y coordinate of the thinnest location is considered normal when it is less than minus 0.500 microns in absolute value, and it is suspected when it is between minus 0.5 and minus 1 millimeters, and when it is larger than 1000 microns or 1 millimeter, then it is abnormal. Finally, I will try to apply all the information said in the first two parts and this part on normal and abnormal tomography. This is a normal tomography. As you see, the anterior sagittal curvature map shows symmetric bow tie without any skewed radial axis. SRAX, and as you see here, there is not much difference between the inferior and superior points. Also, the anterior and posterior elevation maps on the best fit sphere show normal or symmetric hourglass pattern, and on the best fit toric ellipsoid, there are no abnormal values within the central 5 millimeter central zones. This is an abnormal cornea. As you see, it is asymmetric bow tie, inferior steep with SRAX. Obviously, this is keratoconus. And on the best fit sphere, both anterior and posterior elevation maps show tongue-like extensions, and on the best fit toric ellipsoid, there are abnormal values, especially on the posterior surface. This is the end of part 1, diagnostic tools. In the next video, we are going to talk about classifications of keratoconus and ectatic corneal disorders. Thank you very much.